Chrysalis. So Women Who Code Tokyo, Women Who Code itself is a global nonprofit organization dedicated to inspiring women to excel in technology careers. So it's an organization to build a community of women in tech and help them to succeed, to progress in their careers. Here in Tokyo, Women Who Code has chapters in like 60 cities around the world. And here in Tokyo, we have more than 1,000 members. And we run events roughly twice a month, like study sessions or talk nights. We have mentorship nights, and we try to help women in Tokyo to excel in technology careers. So please join us if you're interested in advancing your coding skills or finding career guidance, that kind of thing. We are on meetup.com, we are on Facebook, we are on Twitter. Everywhere, just search for Women Who Code Tokyo and we'll find us. And quickly about Mercati. So, who here doesn't know Mercati? Come on, Tim. Okay, very few people. So yeah, Mercati is a Japanese company. We do a peer-to-peer selling app, like a flea market app, and we have business in Japan and the United States. We have an office in Palo Alto, as well as here in Tokyo, and some other offices as well. Portland, one in Sendai, one in Fukuoka. And yeah, we are a company that we are developing software, and we are going global here in Tokyo. So we have a lot of support for foreigners, especially like we have an amazing global operations team. Hi. They do a bunch of translations and facilitations with a language barrier. It's amazing. We have so many nationalities in the Tokyo office. It's really impressive. And yeah, if you're interested in Mercati, just talk to me or anyone that works on Mercati. Some of them have a Mercati t-shirt. Some of them have the Woody Power badge. You can find them. And we can answer any questions about Mercati. And thank you, Mercati, for hosting us today and for providing food. This is all sponsored. Thank you. And now I'm passing the mic to Coach Chrysalis and Krista. Thank you so much.
Hi everyone, I just need a second.
You're extending.
Yes. Okay, I had a minor panic attack earlier because I forgot the clicker. And Felix over here helped me download an app with my Android phone and connect it to a Mac. So that is what engineers do. They help each other figure it out. So thank you, Felix. All right, so yeah, let's get started. So today we're going to be talking about what the bleep is JavaScript. I'm not actually going to swear because we have a swear jar at Code Chrysalis and I don't want to owe any money. Let's start by, I'll just explain quickly who I am. So I am an instructor over at Code Chrysalis, and then I also co-founded a company based in LA and San Francisco, so I kind of split my time between the two places. I am also someone who never expected I would end up a software engineer, and most of my family doesn't actually believe I am either. Although they do try to get me to fix their phones all the time, and I have to explain I have no idea how to do that. So quick poll, why is everyone here? So there's three options. The first one is you're an engineer, but you don't work in JavaScript. Number two is you're currently learning to code, and number three is you really have no idea what it is. All right, so if you're number 1, please raise your hand. All right, number 2? Okay, and number 3. All right, so tonight's talk is mostly aimed at people for number 2 and 3. We are going to get into JavaScript closer to the end. That piece of paper that looks like alien language, we are going to try to decipher by the end of the talk. But most of the talk is sort of the basics of coding, the building blocks, and what it all means. All right, let's see here. All right, so today's agenda, we're going to talk. I'm going to explain 3 things. What I got wrong about the stereotype of software engineers, the biggest thing I learned about coding, and then what software engineers actually do all day besides browse Reddit. The second thing is we're going to write some pseudocode, and I have a lovely activity we're going to try to power through, and then we're going to read the JavaScript. All right, so let's start. Here's what I got wrong about software engineers. First, turn to the person next to you and talk about what you think the stereotype of a software engineer is like. All right, so turn to the person next to you. What is a software engineer? And introduce yourself. Say hi.
Can I get you to smile? Feels a little weird saying that.
It's just this cake. Whoa.
Okay, so when I thought about that, I thought, okay, I'm obviously never going to be a software engineer. It didn't even cross my mind to think that I would enjoy it because the only Pokemon I can name is Pikachu, much to my fiance's chagrin. I like sunshine so much, I moved to California. I hate being in the basement. I don't wear a hoodie every day, but I do have this dress in 3 different colors, so I guess I kind of wear the same clothes. I do sports. I used to coach sports. I am normal. I use a calculator. I am okay at math. And I enjoy the arts so much that I actually went to college for theater. I paid for 2 years by fake crying during a Shakespeare monologue. That's a true story. And I also am not an introvert. I can't stay alone for more than 8 hours or I get really panicky. I come from a big family and I don't do well when I'm alone. So, if I did not fit the stereotype, why did I learn to code? The answer is in BCE, before coding era. So, where I'm currently at is the part that you know, and I kind of explained, is I became a software engineer. I worked at startups in San Francisco. I started a production company, and I teach at Chrysalis. I've also taught full stack in Spain, and I've done workshops for engineers in Italy as well. So before all that, my life looked a little like this. I managed restaurants. I then went to college for theater and became a theater technical director. which actually wasn't very technical. It was more like lighting design and getting to build things, but not what you'd think it is. And then I became a high school teacher. I taught mythology and video production and high schoolers how to treat each other nicely. Then I went into school district administration, where I trained teachers and worked with librarians. And then I worked across the US in education policy and helped schools bring technology into their classrooms. Did I have to know technology for that job? Not really. It was more project management and dealing with a lot of people. And so what ended up happening was I ended up on a speaker panel to talk about one of those projects, because we were trying to bring technology into schools, and as part of that, trying to get kids to learn coding. So that made me qualified to talk about coding education in schools. Here's the problem. I did not know how to code, and I knew pretty much nothing except what I'd read online. So I got asked to join a speaker panel only because my boss was unable to be there, and I was going to be joined by 3 software engineers. Here's what I expected. Everything that I had seen on, I guess, all of the common television shows. I got there, and just as I expected, I realized I did not belong there. The 3 people next to me were very different from me, but not in the way that I expected. These women were very smart. They were very eloquent. They were very confident. One of them had amazing fashion style, and they were also talking about solving problems in ways I couldn't. And that is not a way I thought about engineering before. I thought there were people in one room who made decisions, and then there were people in another room who just implemented it. And I'm really embarrassed to say that now because I realize that's not the case at all. But at the time, I thought it was, here's the artistic, creative people who decide strategy, and over here are the people who just build it. So the reason stereotypes are so dangerous is not only because they limit us, because they create this idea of us versus them. I know programmers who fit every one of these stereotypes. I know programmers who fit none of these. I know programmers who fit some of them. It doesn't really matter because every programmer I've met shares one quality in common. And that quality is they like to solve problems. That is the one consistent thing I've seen with every single engineer, no matter who they are. And they're pretty good at it. And so I was pretty jealous, so I decided to learn to code. Oh boy. So that was not easy, and we'll get into that. But first I have a question. All right, so before I share the biggest secret I learned about coding, I want to know what is stopping you from learning if you have not learned yet, or if you already do know how to code, what scared you when you started learning? What are your fears about learning to code? All right? So turn to the person next to you and talk about what is holding you back from learning how to code. And then I'll share what held me back. All right, go.
Let's do this again.
More seconds.
Yeah.
Okay, so the reasons I was afraid to learn is because I didn't think I was smart enough. I didn't think people would take me seriously. I started learning when I was about to turn 30, and there was no way I was going back to get another 4-year degree. I was afraid I was throwing away the career I had spent a decade building, and I was starting over from scratch. And I was also afraid because I didn't have a background in math, and everyone told me that's what I needed. So those are the big 4 reasons I was afraid to learn. And here's why none of these things mattered. I was afraid I wasn't smart enough, but it didn't matter because even though it was hard to learn, it was hard like everything else I had never spent time trying to learn before. Like if you've never learned it, of course it's going to be hard. And there's a lot of research that talks about something called a growth mindset. There's a researcher out of Stanford University in California who talks about how intelligence is not fixed. And we call this a growth mindset versus a fixed mindset. And so whenever I felt like I wouldn't get it, I had to say, I'm not good at math yet. I'm not good at 8 times 7 yet. I'm not good at 7 times 8 yet. And I kept saying the word yet to myself until I finally got it. And so I had to be comfortable with the fact that yes, I didn't know it yet, but yes, I would learn it. I just had to keep trying. So that fear went away. I was also afraid I wouldn't be taken seriously. And yes, some people did not take me seriously. Some people still probably don't. But you know what? Again, that doesn't matter because that happens in literally every industry. I had been working in education for a while, and one of the expectations in with a lot of the roles that I was interacting with was that I would get a PhD in education. And just like in computer science, there are PhDs in computer science. There are PhDs in technical theater, light design. You know, anything that you do is going to have an expert. And I had to be comfortable with the fact that I could only keep getting better. There's another book that's really popular in education theory called How People Learn. And they call experts, the best kind of experts, accomplished novices. And there is a software engineer I met at my very first job who was the perfect example of this. He was incredibly smart. He did front-end work and left Apple to join the startup I worked at. He decided to start learning some back-end stuff and Python while we were there. And he would ask some of the silliest questions. And I had just learned it, but I was trying to appear really smart, so I didn't like asking questions. I tried to figure it out and brute force my way through it. And he would just ask questions like, what's that? What does that do? Why is that from there? And I realized the reason he's so smart is because he has no ego about what he doesn't know. He would just keep asking questions. And so he was very accomplished, but he didn't see himself as an expert. And I realized that's what I want to be like. So the better questions are, can you do the job, and will you continue to learn? Because credentials, no matter where they come from, are simply a form of currency. They're only as important as the value that we ascribe to them. Oh no, connection failed. All right. The third thing is I was afraid I was throwing away my career. And the thing that I didn't know at the time is that I underestimated the value in being a hybrid. So there's a lot of studies that talk about the importance of being able to dot connect between different industries. I had spent so much time in education and I thought I was just throwing that away. But what it turned out is that I didn't get rid of that network and I didn't get rid of that knowledge. I was just able to now connect it with technology in a way I couldn't before. And so I've actually had better opportunities since learning a completely different industry. My fiance is learning to code right now and he's been a filmmaker forever. And I can see this difference in how he looks at things versus how I look at things. We recently went to a VR museum and I was like, cool, I'm a panda now. And he was like, oh, this reminds me of Edward Muybridge, the filmmaker who first started talking, I don't even know, I was listening, I promise I was, but he was able to dot connect these things in ways I couldn't. And so that's the value of learning something when you start somewhere else. You're able to dot connect. And finally, the last thing I was afraid of is that I didn't know enough math. And that really didn't matter. So here's the thing. There is a connection Math helps because math is structured logically. And when you learn math, you learn things like algorithms or statistics. And if you're going to go into data science or machine learning, that's really helpful. But for the average software engineer, you might not be using that kind of stuff. And I realize there's something that's a lot more important than math. And this is the biggest secret I learned about coding. Coding is not about math. Coding is actually about communication. And so to explain, we're going to take a quick deep dive into the history of computing before the age of selfies. So this is an original computer. And the early ones used vacuum tubes. And so they used on-off switches to calculate different things. And so we know that as binary code. So zeros and ones, on, off, on, off, on, off. The first electromechanical computer weighed 5 tons and had 750,000 parts. It was absolutely massive. This was about the 1940s. For a comparison, this massive computer took about 6 seconds to calculate one multiplication problem. In comparison, the iPhone 6 in 1 second can do 26 billion instructions. So we've gotten a lot more advanced. So there was a woman named Lieutenant Grace Hopper, and she was tasked with running calculations on this machine. And as you can imagine, with 750,000 different parts, mostly mechanical, there were a lot of issues. Issues from switches flipped incorrectly to even finding real bugs stuck in the machine. So her and her colleagues started collecting subroutines. Basically, they were running certain tasks over and over and over. And sometimes there'd be a mistake the 4th time they'd run it. So they'd say, why don't we just write this down, these instructions, so we don't keep messing this up? It's kind of like baking a cake. Your mom has this recipe or your dad has this recipe and they keep telling you what it is. And finally you say, can you just write that down for me? And that's what she did. So she tried to convince her employer to turn these into normal words because what they were doing was using basically pieces of paper with holes punched in them. And she said, let's use normal words to make this easier, like subtract the sale price. But her employees were not interested because they ran slower. And this is why they ran slower. Machines run a lot faster on low-level languages. So binary machine code is just zeros and ones. The machine can process that instantly. If we're using a high-level programming language like this, real words, first we have to compile it down so that the machine can read it. So that's what Grace did. She wrote a compiler in her free time. So a compiler transforms one programming language into another. So a high-level language is something that looks like what we know. It's like a normal spoken language with some different syntax. That gets compiled down into assembly code, which looks like this. And this is the current process, which then gets compiled down into machine code. And there's a little more to it than that, but essentially that's how we get from JavaScript all the way down to something that your machine can read. So Grace writes this compiler, and other programmers from all over start sending her different instructions because they're like, this is awesome, I want to get involved. And this is kind of the basis of what we call open source software. And there's a huge community of engineers who are constantly creating software that they just share with each other, and you use these different frameworks and libraries in everything you use. So you don't have to constantly be writing everything from scratch. This programming language evolved into one of the very first ones called COBOL. So this is the key thing here. Programming languages aren't actually built for machines. They're built for humans. That's why they look like something we know. They get compiled to machines, yes, but they are written for humans. So you don't actually learn this stuff. You learn that one. And because they're built for humans, they're modeled after spoken languages. And so new programming languages come up every couple years, and they're all a little bit different, but they use words that we recognize. So just like spoken languages, programming languages use a lot of punctuation. Some use more than others. Python doesn't use a lot of punctuation. JavaScript tends to go a little overboard. But all of these punctuation marks you see in a normal spoken or written language. Just like spoken languages, we may use different words, but the structure of the sentence is generally the same. So there's a difference between English and Spanish and Japanese, but all of them have nouns and verbs and adjectives, right? The same thing happens with programming languages. So here's the difference between JavaScript and Python. You can see both of them have an if-else and a return. All right, so they're very similar. They're different, but they share some of these same fundamental things. And all programming languages have things like loops, or for this many times do this, or if this, then this, or you have a function to repeat certain ideas. So that's the structure. There's also dialects. So there's slightly different versions of what you already know. And so in JavaScript we have things like TypeScript or CoffeeScript. Languages also evolve. So every language evolves over time and words become more popular or less popular. Emoji did not exist how many years ago, and now it's back, which actually is kind of like petroglyphs all over again. But this is a difference between JavaScript ES5 and ES6. So about 2016 there was a massive update to what we know as JavaScript. These do the exact same thing. It's just a different way of writing it. So we're constantly trying to get a little bit cleaner and a little more specific. And just like spoken languages, programming languages have a group of super nerds who define the standards. This was my favorite part about being a writing major. There is a difference between MLA and APA style, and it was actually really important for me to know this when I was going through university. I was super excited to find out that there is also a manual that describes the syntax of a programming language. And because of that, just like spoken languages, people get into arguments over style preferences. So the big joke is spaces versus tabs in programming. That is the exact same argument as the Oxford comma for a lot of people who do writing. And so the Oxford comma is that thing where you do this, comma, and this. Do you put the comma before the and? I say yes. People also say no. So I've gotten in arguments about that. Programmers get in arguments about spaces versus tabs. So programmers are basically writing this essay at the same time, on top of each other, and they're doing it as a team. And so if you're doing that, communication actually really, really matters. Because as a writer, you need people to know what you're talking about. And you also need to make sure that someone else can add to what you've written before. So if anything, communication is actually more important as a programmer than in probably most other industries. And that's the biggest secret I learned about coding. It is about communication. You write code. You are constantly reading code, including reading documentation. You are constantly talking about code and trying to figure out if things make sense. Did we pick the right word for this? Should it be plural? Should the function be named that? You're editing each other's code, which is a lot like reviewing someone else's essay and saying, well, I think it would be better if we did it this way. Syntax really matters. If you don't use it correctly, it won't work, or it'll be less efficient. Things like flow really matter. Is this the most logical way to write this? Style matters. You want to have consistent style with all the other programmers, and word choice really matters. So basically, what I've learned as a programmer is it is probably the best use of my university degree that I did not expect, because it's a lot about communication. Okay, so that's part 2. So before, we'll get to what software engineers actually do all day. We're going to take a break and take another conversation. What do you think software engineers do all day, and how close or far do you think it is from what you currently do? All right, so take a second to talk about that, and then we'll talk again.
Step too far away. It's working again.
All right, 30 seconds. All right, so that was like 10 seconds, I'm sorry. All right, so let's do what software engineers actually do all day. So this is not research-based in any way, this is just based on my experiences, but let's play a game with it. All right, so here are the rules. We're gonna go through the top 10 tasks I did as a software engineer, and for every task, I'm gonna share a related skill. And then if you think you have this skill, I want you to give yourself a point. Now, do not do what a lot of people do, which is be shy about giving yourself a point. All right, I want you to give yourself a point. And to drive this point home, I want to remind you that research shows women will not apply for a job unless they're 100% qualified, and men will apply when they're only 50% qualified. So ladies, give yourself the point, all right? All right, so number one. So as a software engineer, I would collaborate with product managers, designers, and other engineers to implement new features. What does that mean? All right, so that's the task. There is a related skill. It's different. So to explain this one, I'm going to give a quick little story, and it's a true story about 4 pumpkins. And these pictures are fake. I found them on Google, but the story is true. All right, so at a startup, I had to work with designers and product managers, front-end engineers, back-end engineers, and customer support. I was in a weird role. I was the only full-stack engineer there, so I was kind of in the middle of these two teams. But I also like to paint a lot, so I hung out with the designers, and customer support was a lot of fun, so I liked them too. So I liked everybody. But during Halloween, in the US, we had this, I guess, tradition where you carve pumpkins, and you kind of put a face on them. And so we had a party, and basically every single team got a pumpkin, and they were told, make a carved pumpkin, and then you can go get snacks. Can you guess what happened? Well, this is what the designers and product managers basically produced. It was 3D, there were parts sticking out, and we were all like, what is that? The front-end engineers, no joke, went to the internet, printed out a design, taped it to the front of the pumpkin, and then just cut it out. So if you know anything about front-end engineers, usually they're given the design by the designers, and then they follow the instructions of where to put the buttons and how many pixels to move it over. Thought that was hilarious. The back-end engineers did this. So to explain this joke, MVP stands for minimum viable product. And it's something that engineers use a lot to produce the smallest version to solve the problem that they can do. So they ran and grabbed a marker, wrote MVP on their pumpkin, and then went and grabbed a beer. We solved the problem. And then finally, customer support. This is my favorite. Someone thought ahead, brought a little spigot, and turned it into a keg so they could serve beer out of it. And what I learned from this is that different roles have different goals. Designers wanted to make it look awesome. Front-end engineers wanted to make it look awesome, but also wanted someone to tell them how to make it look awesome. Back-end engineers were like, we just want to solve the problem and get it over with. And customer support is like, but the people, we have to make the people happy. So you need all of these people to make a company work. And so what I learned is that the related skill with this task is actually a very soft skill, which is, do you know how to work with people who have different goals and get them to work together? If you think you can do this, or if you think you've done it in the past, or if you think you're like 50% there, give yourself a point. All right? All right, number 2. As a software engineer, I would make technical designs and get people to agree on a plan. All those 4 pumpkins we discussed earlier. And this often involved drawing diagrams. I like that part. So this is also a soft skill. Do you know how to explain abstract concepts? There is a pizza metaphor we use very often, actually you'll see it later in this presentation, that came from me talking with a product manager about how all of our architecture worked. And so that was a lot of fun, is how do you get someone who might not have a background in something to understand where you're trying to go. All right, so give yourself a point if you think you can explain abstract concepts. All right, number 3. Software engineers break tasks into smaller issues and prioritize them appropriately. So basically, can you just get stuff done? And that's a very soft skill. Some people have it better than others. My younger sister is probably the best at this that I've ever met. So give yourself a point if you can get stuff done and make to-do lists. Number 4. Software engineers constantly learn new languages and frameworks because a new framework comes out every 3 months, and new technologies. So another soft skill. Do you know how to be a learner? If you think you can learn new things on your own or through the internet or through talking to other people or through coming to meetups, give yourself a point. Actually, you can all take a point for that. You all came to meetup. All right. Number 5, software engineers have to be very specific and thorough to avoid mistakes or bugs. All right, I put a picture of 2 little boys here because my sister, again, is probably the best at this of anyone I've ever met. For her wedding, she ended up putting out a bunch of tables had place settings that had different utensils, different cups and spoons, and coloring books because kids were going to be there. And she's like, I can't have them near knives, I can't have them near glasses, and they need to have something to distract them. Like, she planned ahead and was like, this is a mistake waiting to happen. And so, as an engineer, I know she would be the best at finding every bug before it actually happened. So, another soft skill, can you predict things that could go wrong and plan ahead to prevent them from happening? Give yourself a point. All right, number 6. Software engineers solve bugs and fix problems even when they have no idea what the solution is. Bet you can all guess what the soft skill here is. Do you know how to Google? If you can, give yourself a point. You can also get better at Googling. I've gotten a lot better. All right. Software engineers also help each other and sometimes draw on windows because it looks cool. It's not practical at all, but it's a lot of fun. So again, another soft skill. Do you know how to teach other people what you know? Software engineers are always teaching each other. Give yourself a point. Number 8, software engineers review each other's code. Because we are writing this interactive essay together, we're constantly looking at each other's code and giving feedback. This is actually a lot like what it felt like to be a teacher. I was constantly looking at students writing. Now I look at other engineers writing. Words matter, it's great. Again, do you know how to give and receive feedback? Another soft skill. If so, give yourself a point. All right, number 9. Software engineers automate repetitive or time-consuming tasks. I'm not sure if this is a soft skill, but I think it's my favorite. Do you know how to be purposefully lazy? If so, give yourself a point. And finally, the last one, software engineers write code. Now, we talked earlier about how coding is communication. So people say that coding is technical, but I would argue, based on what I went through in university and teaching to students, that this is not very different. Do you know how to write in a structured and logical way and use proper syntax? So if you think you have that, give yourself a point, because I would argue, even though you might not know JavaScript or Python or Ruby or whatever language it is yet, if you can do that, you've already got the skill to do it, because that is a soft skill. All right, how many points did you give yourself? You can hold your hands up. 10. All right. I heard one person say 10. That makes me happy. All right. So here's the reality. Good programmers work well with others. They explain abstract concepts. They make to-do lists. They learn new things. They predict mistakes. They Google. They teach others. They give and receive feedback. And they try to automate things. And finally, they write well, which means programming is literally like every other job anywhere. It's just you've learned another language. Because any job I've ever done, I've had to do all of those things. So that is the end of the talk portion. We are going to take a 5-minute break, and then we're going to jump into the next activity. So please grab more food. Thank you. All right, try to make your way back to your seat for the next activity. All right, so for this one, you're going to need a partner. So please find a partner, and if there's someone around you that does not have a partner, form a group of 3. And a pen or pencil, and one person can use their piece of paper. So you can use the Morse code side if you need to find something to write on. All right, so everybody look around you. Does everybody near you have a partner? Okay, good. All right, so we are going to write some code, and more specifically, we're going to write pseudocode. So what is pseudocode? So earlier we talked about low level. You're definitely not going to write machine code. We're also not going to be writing a high level programming language yet. We're going to read it, but you're not going to write it yet. You're going to write something called pseudocode, which is basically the same as code, but instead of using a programming language someone else created, you're going to use one that you created, which is your normal language. So basically, pseudocode is just saying what you want the code to do. And sometimes when you're trying to work through a really difficult problem or an algorithm, you'll write the pseudocode first. I want it to do this, this, and this. And then you'll translate it into JavaScript or Python or whatever language you're using. All right, so you're going to write pseudocode, which still counts as code, I think. All right, so for this activity, here's what's going to happen. I have in front of me, I'm going to move this, a package of bread, a knife, I have a piece of paper towel down so it doesn't get messy, and a thing of jam. All right? I would like you and your partner to write instructions for me to basically put jam on a piece of bread. That's it. All right, so you need to give me instructions for this. I'm going to take some volunteers after the time is up, and I want you to read your instructions to me. Now there's a couple rules. After you finish writing your instructions, no matter what I do, you cannot change your instructions. All right, so you still have to read directly off the piece of paper. The second rule, actually that's the only rule. You just can't change the instructions once they start. Some tips: be logical, be specific, and plan for all scenarios. So these are the soft skills we talked about earlier, all right? You gotta be very specific, and you gotta plan for anything, because I'm gonna be a robot, and I'm just gonna take whatever you say super literally, all right? So that's it. You've got, let's say, 5 minutes. I'm going to put a timer up. Yes? The task is to tell me, the robot, how to put jam on bread. All right? I've got a knife, I've got a loaf of bread, and I've got jam. Good luck. All right, so here is my stuff. Connie, who is the CEO of Code Chrysalis, this is Connie, everyone, will be coming around with a microphone. I know robots in Japan talk, but I'm not going to be a talking robot, so. All right. So who wants to try?
All right. So open the plastic bag containing the bread. Take one slice of bread out of the bag.
Oh my god.
Place slice of bread on the paper towel. Yeah. Well, place the bag containing the rest of the bread back on the table and free your hands. So with your left hand,
They're free.
hold still the jar. While with the other hand, you turn the jar lid clockwise until the lid comes up. Infinite loop.
Up. It's up.
It's hot. No.
Place the lid on the table. With your right hand, pick the knife. Then, using the knife, take some jam on the knife. Good stuff. And now at this point, put the jam on the bread using the knife in your right hand. Good.
All right, thank you. All right, another volunteer.
Okay. Turn towards table, walk to table, and stop. No. Okay. This is gonna be fun. Okay, reach out to the jam with your left hand. Grab jar. Good luck. Okay, grab the lid with your right hand, and with your right hand, turn it counterclockwise. Well, you're supposed to remove the lid and drop the lid to the table.
I'll be nice.
Okay, turn towards the bread. Fair enough. Turn towards the bread. Open the bag with both hands.
Okay.
Again. And then take out one slice of bread and put it on the table. Okay. Grab the knife with your right hand. Move the knife to the jar. Put the knife in the jar. And then scoop jam gently with the knife.
With the knife.
Once.
Once?
And then move knife towards the slice of bread.
Yeah.
And then spread jam gently onto the slice of bread 3 times. eat it.
That was successful. Good job. All right. Oh, I got paper towels right here. Okay, I think that was good. So talk with your partner right now and see if you can figure out where yours would have worked or would have failed. All right, so take a minute or two to do that.
Also suddenly this is love, like it's hard to move.
Pseudocoding and writing programs for robots.
Exceptionally detailed.
Being exceptionally detailed, yes. I've actually been a lot meaner in the past. If someone said, pick up the knife, I'd pick it up with my mouth. I've gotten jam actually in my hair about 50% of the time I do that activity, so this one went okay. What else? What else did you learn?
Don't assume.
Don't assume anything. Yeah, that's a big one. There's lots of tables here. Someone else said, go get the bread from the store in one of the ones I did, and I was like, see ya. For an uncomfortably long amount of time. What else? What else did you learn?
Machines are stupid.
Machines are stupid. Yeah, humans fill in the blanks a lot, but humans know nothing. That's why it's so hard for machines to do a lot of things. Pepper is really smart, I learned, but that's about it. Like, Pepper's the height of our robot intelligence. What else? Yeah.
And it's almost like teaching a baby.
Yes! Yes.
When you're using words instead of like showing the baby. I mean, I don't have a baby, but it's probably...
No, that's exactly it. There's actually, the time that this activity went the best was with a room full of teachers who taught kindergarten, actually. They nailed it, and they're like, yeah, we do this every day. And it's like, oh, okay. So, yeah, that was exactly it. One more thing, what else? Yeah?
There are many ways to solve a problem.
Yeah, there are many, many ways to solve a problem. And it's also true with any type of program you write. You can write it a lot of different ways, and they're not necessarily better than the others. Some might be a little more efficient, some might have better space or time complexity, so they might take up more space in your program, or they might be a little bit faster. But there's generally a lot of different ways to solve it, and the only answer is really, does it work? And how much time did that take me? Which is why MVP Pumpkin usually wins. All right, so we're gonna read some code. The piece of paper in front of you has JavaScript on one side, Morse code on the other. We do have extra pieces of paper if you wrote on the JavaScript side. You need that side to be clear. So if you need another piece of paper, go ahead and grab another piece of paper now. And then we'll start. right, so this alien language in front of you is JavaScript, and our goal by the end of this next section is for you to understand kind of what's going on in it. It's pretty complicated, actually. There's a lot of the fundamentals of programming in this function. We're using conditionals, we're using loops, we're even using a nested object and array. So a data structure that's a little more complicated. So here's how this is going to work. First, I'm going to talk a little bit about JavaScript, and then I'm going to explain different concepts that exist across all programming languages, but with the syntax of JavaScript, you're going to write on your piece of paper and then try to understand what it's saying. All right? So, first of all, let's talk about JavaScript. JavaScript is a high-level programming language. So that means it's on the far left of that diagram we looked at earlier. It gets compiled down into assembly code, then down into machine code. And so this is one of the ones that's considered top level that humans write. It's also one of the 3 core technologies of the internet. Does anyone know what the other 2 are? Yes, HTML and CSS. So these are like the big 3, HTML, CSS, and JavaScript. One of the most common implementations server-side of JavaScript is Node. And what's really cool is if you actually open up your browser, let me do it right now, I can use JavaScript right here and it'll work. So if I do something like 3 + 4, boom, 7. It's using JavaScript right now in my browser. And so as far as programming languages to learn, JavaScript is becoming and has been one of the most useful because of where it is used and how it can be used. There's a lot of common frameworks and libraries that have come out in support of JavaScript in the last 10 years. And more it's becoming sort of the main language that a lot of people end up learning. As far as what all I was talking about when I said server side, this is the metaphor. Basically, if you understand how a pizza is made, you understand how server architecture or system architecture works. So we have basically 3 things in the average app. You have something called a client or front end, and that is what you see. So if we're at a pizza restaurant, that is the pizza. Someone makes the pizza, they assemble the pizza, and they show you the pizza. Back end, or server side, is where all the ingredients come from and where they're organized, and maybe there's a meat factory, a vegetable factory, and they're the ones deciding, here's the factory, here's how to get it back and forth from this. The database is actually where it's stored. And so this is usually connected in some way to the server, and so this is where it actually comes from. So when we talk about front-end engineers, we're talking about the person who makes the pizza. When we're talking about back-end engineers, we're talking about the person who sends the ingredients back and forth, and data engineers are usually the ones who decide where to store the ingredients. If you're full stack, you generally do all 3 sort of. JavaScript can be used both front-end and back-end. All right, so that's a brief overview of JavaScript. This is the actual language, so we're going to go into the syntax of what it looks like. All right, so ideally you'll work with the same partners. If you get stuck, talk to each other. It's always better in pairs. All right, so the first thing is variables. Every language has this. I am using an older version of JavaScript for this. We've actually upgraded to use a different keyword for it, but ES5 used the keyword var. It's very easy to recognize, var variable. So this is a keyword that JavaScript recognizes. So when your machine's looking at the code and the compiler is, it sees var and it says, oh, that's a variable. The next thing after this is probably the variable name. Variables are basically containers. So it is a container that has a name and allows you to refer to whatever it is later in the code. And so var is the keyword. The name of this container, we're saying, is job. And then the assignment operator is an equal sign. And we're saying var job equals engineer. So later, if we say job, what's it going to give us? Engineer. We can also say var job equals teacher. Now job equals teacher. So we can take things in and out of this container. We can switch it all we want. What's important is we have a container now, and it is called job. All right, so on your piece of paper, your challenge is to circle all the names of variables in your code. All right? And you'll see some of them appear more than once. Try to circle it in the place that it is declared. So you'll see the word var, you'll probably see a name, and then you'll see the equal sign afterwards. You want to circle the name of that variable. All right? Good luck. Alright, so from the top, what do we got? We've got Morse code. I see word in Morse, letter position or letter POS, current letter, dash, current dash, and word in Morse. Did I miss any? Alright. Let's go to the next thing, data types. Alright, so there's more data types than just this. These are some of the main primitive ones we use. We call them primitives because they're the most basic part. We've got strings, we've got booleans, and we've got numbers. So a string is usually something that's in quotes, and it refers to a phrase or a word, but that is the data type. A boolean is true or false. And true and false are also recognized. You have to spell it exactly true or false. And then the last one is a number. All right, so here we've got a string, an example of a string, an example of a boolean, an example of a number. So the way to tell the difference is a number is a number without quotes. Boolean is either true or false, and string has quotes around it. So now, back at some of these things where you've identified the variables, see if you can now label them as either strings, booleans, or numbers. All right, so go through your code and label each of those variables. Are they strings, are they booleans, or are they numbers? All right, does anyone have any questions? Okay. All right, so let's talk about operators. This is also something that's universal to every programming language. Here's some common operators. Kind of looks like math. We have less than here, we've got is equal to, we've got plus one, and then we have plus equals. So plus one is the same as saying take that number and add 1 to it. This plus equals is saying take that number, add the next number to that previous number, and store it there. Is equal to is a comparison. We can't use one equal sign when we do a comparison operator. Does anyone know why? Oh, I thought I heard someone say something. Do you want to explain why? It's an assignment, yeah. So we just saw one equal sign as an assignment operator. So if you have one equal sign, your machine's going to go through that and be like, oh, you're assigning something here. So that's already reserved as an assignment. So if you want to compare things in JavaScript, you have to use 3. At one point you had to use 2, but that was a big mistake, so now we use 3. So over here, var dash equals 0. This is an assignment operator. We're saying dash is 0. Now, dash plus plus. What does dash equal now? 1. Now, dash plus equals 3. What does dash equal now? 4. Now, does dash equal 4? Yes, that is true. So that's the difference between all of them. All right. So here's a challenge. Try to label all the operators in your code. You've got some plus equals. You've also got some equals equals equals. And you've got some plus pluses. Do not accidentally label the assignment operator as a comparison operator. All right? Remember, comparisons need 3 equal signs. And so when you label these, maybe say what they're doing, like adds 1, or adds this, or compares. All right, next thing, let's talk about conditionals. All right, just like operators and variables, every programming language has conditionals. Here's a conditional statement. If this, do that. Else, do this. This is one of the most common basic things that most programs need. So here's an example in JavaScript. If, and then you'll see I've got open and close parentheses, whether equals 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 cold, so this is going to turn out to either be true or false. If it's true, I'm going to do the stuff that's in between the curly brackets. Otherwise, I'm going to do the stuff in between the other curly brackets. So curly brackets in JavaScript are used a lot for the body of things, whether it's the body of a function, which you'll learn about, or the body of conditionals, but usually between curly brackets, you do things. And in between parentheses, you often evaluate things. So your challenge now is, next to the conditionals in your code, try to explain what is happening in normal written language. So let's go to the first one. If current letter equals equals equals, and then you see 2 quotes with a space in it, you have to do something else. Otherwise, do something else. So see if you can kind of explain that in common language. All right, so let's actually review this one before we go further. So the first if statement, if current letter equals a space, what are we doing to word in Morse? Who's got an answer? +1. Plus, not quite +1. Plus, yes, empty space, a bigger empty space. Yeah. So if current letter equals, so if current letter is an empty space, then word in Morse, we add to the word in Morse 3 spaces. All right, so this will all make a little more sense later. On the otherwise, we do the other thing, and we'll talk about the other thing later. The other if statement says, if the current dash is 3, then what do we add to word in Morse? Yeah, like a hyphen. Otherwise, we add a dot. All right? So, I'll explain more in a bit, but that's what that's doing. All right. Next thing, functions. All right, functions allow us to do the same thing over and over and over. So, we use functions to store repeatable actions. So if I am constantly spreading jam back and forth, you don't want to say spread jam again, spread jam again. You're either going to create a loop where I spread jam until I'm told to stop, or you create a function so every time I want bread, I know, oh, spread the jam. All right, here's another function. It's a new day. Spread the jam. All right, so functions are, you can recognize a function by the word function. All right, so the word function is literally a keyword for JavaScript, and that's how we know it's a function. Functions do not have to return something, but a lot of functions do. A clean function does. And so inside of the function, you will see something that says return potentially. And then, kind of like the conditional, in between the curly brackets is where things happen. Functions also have 2 other things. They have a parameter that they take, and so there's a word that goes after the name of the function, so it takes a parameter, and then you pass in an argument when you call it. So, before that challenge, here's an example. We have a function called add5. It takes x, and it returns x plus 5. So, down here, when I call add5 with the argument 7, the function runs, and it now sees x as 7. And so it's going to return 7 plus 5. I can use it again. I'm going to say add5, pass in 3. The function is called, x is now 3. 3 plus 5. All right? So you have one function in your code. And what I want you to do is try to draw a square around the argument. All right? So the argument is the thing that gets passed in when the function gets called. All right? So you'll see the function somewhere near the top, probably defined. Find where the function is called and try to put a square around the argument. All right, who figured out what the argument was? Yes. Yes, the string we can read code. All right. What is the name of the parameter that the argument is linked to? Does anyone know? Yeah. Phrase. Cool. So because we are passing in, I don't know why I'm looking here like it's here. It's right in front of me. Okay. Because we're passing in the string we can read code as an argument, inside of this function, when it's called, we now see we can read code as phrase. So if you see phrase anywhere, phrase is now the string we can read code. Okay? Does anyone see phrase.length? Yeah, what do you think that's doing?
Number of characters?
Yeah, number of characters in the string. Okay? So that actually makes it a little easier to start figuring things out. So the number of characters in we can read code is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 characters. Alright? So where it says phrase.length, put the number 16 above it. That'll help later when we look at for loops. Alright, but first we're going to look at data structures. So this is a more advanced way to store data. So JavaScript has two that we use most commonly. Technically, pretty much everything in JavaScript is an object, but for the sake of this, we're just going to talk about arrays and objects. So data structures are used to store multiple things in one variable. And so why would we want to do that? Because we like stuff. But the values that you can store can be any data type. And so you can have an array that has strings and numbers and booleans, and you can have objects that have a mix of all of them. It doesn't really matter. What's important is that they have to be structured a certain way. And so we're going to go through each. Arrays are 0 indexed, and objects use keys. What does that mean? So let's start with arrays, because I think they're a little easier to think about. All right, so arrays, you can tell something's an array because it uses square brackets around the items. And every single item is separated with a comma. Now, here I just have an array of strings. I could also have apple, orange, true, and 42. Doesn't matter. I can store a bunch of different things. But I know it's an array because it has square brackets around it. I also know it is called fruit because I'm using the variable keyword to say this is a variable, its name is fruit, and I'm assigning it with the equal sign to this array. And here are the index positions. All right, it starts at 0. So the length of this array is 1, 2, 3, 4, but the last index is 3. So the last index is always 1 less than the number of things in the array. Now, here is why I like teaching in other countries. This was really hard for me to think about, and one of my students in Spain said, oh, like an apartment. So I don't think it's the same thing here, but they have ground floors in Spain because there's a rule that you can only build apartments to a certain height. So people would put in an extra floor and say, actually, this isn't a floor, it's floor 0. And so arrays are like European apartments. Basically, you start at 0, and then you go up. All right, so how do you access items in this array? So let's say I want to get apple out of the array. I have to say fruit at 0. All right, so I put a number in between these brackets, and that will give me apple. All right, ooh, that was too quick. What's fruit at 3? What do you think? Kiwi. Fruit at 4? Undefined, all right? So even though there's 4 items, I can't do fruit at 4 because it doesn't exist. All right, so let's look at objects. They're very similar. So objects are separated with curly brackets. Instead of having 0, 1, 2, 3, 4 to separate each item and recognize them, we actually have something called a key. And so every key has a value. So this key is connected to this value, and this key is connected to this value. So if we were trying to recreate fruit, the array, as an object, we would probably say var fruit equals curly bracket 0 colon apple, 1 colon orange, 2 colon banana, 3 colon kiwi. The reason we do objects instead of arrays is because sometimes that information of where it's stored is really, really important. It's also very fast to look something up. All right, so how do you access values? Pretty much the same as how you access them in an array. So this is using bracket notation. You can also use something called dot notation, but we're not going to talk about that. So instead of passing in the 0, 1, or 2, we're going to pass in the key. So if I were to say person at coder, what should I get back? True. Yeah, person at coder. True. You can also, and this is important, pass in variables that represent strings. So if I say var info equals name, now info is holding the string name. So if I say person at info, what I'm really saying is person at name. So what's the answer to that? Mary, yeah. So this is happening in your code where we're holding a string in a variable and then passing that variable into a bracket. And this is where it's happening. Objects array. We got super complicated because it's fun. So let's try to figure this out. What does each of these return? So Morse code at C. What does that return? Yeah, Morse code at C returns the array 313131. Actually, whoop. Oh no, the answers aren't in there. Yeah, so Morse code at C returns the array 313131. What about Morse code at A at 1?
3.
Yes, Morse code at A at 1. So you go Morse code at A, and so you get the array of 1, 3, and then at 1 is the second item because they start at 0. So we get back the number 3. Morse code at D at 0. No one say it out loud, take a look, and then I want you to hold up the number that you think it is. Morse code at D at 0. If you think it's a 1 or if you think it's a 3, hold up your hand. Yep, correct answer is 3. So Morse code at D returns the array 311, and then at 0 is the first item in that array. All right, so here's your challenge. I want you to identify the places in your code where you are accessing items from data structures. There's only 2 places. Current letter equals phrase at letter position is not one of the answers, and I'll explain why in a bit. Alright, so let's talk about it. Alright, so var current letter equals phrase at letter position. So we know that phrase is actually the string we can read code. Now, I'm using a variable, I chose the name for my variable, letter position, to make it easier. We haven't talked about for loops yet, but what you need to know is letter position is a number. And it's always going to be a number in this situation. And so when we say we can read code at this position, you can actually access the character in a string similar to how you access items from arrays or objects. And so current letter is going to be each letter of we can read code one at a time. It's going to be the W, and then it's going to be the E, then the C, and so on. And then actually the space in between that. So then if you go down to the else statement, we say dash equals 0, as long as dash is less than Morse code at current letter dot length. All right, so Morse code is an object. Morse code at current letter. So Morse code, we know the current letter is probably like the letter W, the letter E, the letter A, whatever. If we're doing Morse code at A, that's actually giving us back an array. So when we say Morse code at current letter, it's giving back an array of either 1s or 3s. All right, so where it says Morse code at current letter dot length, go ahead and put this is an array. This returns an array. So Morse code at current letter is an array. Then on the next line, current dash equals Morse code at current letter at dash. This is even more complicated. So Morse code at current letter returns an array, at dash returns an item in that array. So current dash is either a 3 or a 1. So that's where we access them. If you got that like 20%, that's okay. We'll spend a little more time. All right, this is the last thing, loops. All right, so you have 2 loops inside of your code. This is not a very efficient function. 4 is the keyword that tells us it's going to be a loop. There's 3 parts to a for loop. The first part is where we start it. And so in this situation, we're saying start at 0. Then, until that count is less than 4, add 1 to it after every single loop. So what's happening here is we're saying start at 0. As long as we're less than 4, do the thing between the curly brackets, and every time you do the thing, add 1 to that number. And so we're going to do this 4 times. All right? So here's your challenge. I want you to draw a line around the body of the loops in the code. And so this is a little hard to see because you have a curly bracket at the end of the line, and then you have a curly bracket kind of like on the far left side. So the way I like to do this is to draw it straight from the word for down to the curly bracket that connects it. And that's how you know where it starts and where it ends. So find the word for and draw straight down to the curly bracket that's directly below it, in line with it. And you have to do this twice. And those are the loops. So everything that happens between the word for and the curly bracket that is directly in line with it is what's going to happen in a loop. All right, so this is the scary part. All right, I want you to try to figure out what this code is doing. I'm going to give you about 2 minutes, and then we're going to go through it together and actually run the code so you can see what's happening. I'm going to add comments to it, and then we'll see it printing. We've only got about 5 minutes left. I don't want to run too far over time, so let's go. Try to figure out what this code's doing. All right, take about one more minute and then we're going to go through the code. All right, try to wrap up your conversations. All right, so first of all, this is really hard. I'm going to be honest, I did not go light on you. This is a very complicated function. You've got for loops, you've got conditionals. You're dealing with a nested object. This is not something that people would usually not see until they kind of understand most of JavaScript. So if any of it made sense, you're doing okay. The reason I started you out so hard is because if you were to now go to some online course like Code Academy and see 3 + 4, you'll be like, oh, I totally got this, all right? So this is really complicated. You will probably, actually, if you do go to Code Academy and do that entire course and then come back to this, you'll be like, I can't believe I sort of understood that, you know, how many months ago. So go easy on yourself if it was confusing. It was intentionally confusing because I wanted to see how much you could understand. All right, so who thinks they know what this function is doing? Like in a phrase, what is this function doing?
Converting to Morse?
Yes, it is converting a word to Morse. Do you think you could have figured that out without understanding most of the code? Probably. Did anyone see what the function is named? Yeah, all right, so Earlier we talked about why communication is so important in programming. You want your code to be self-explanatory. So a good name for a function is something that tells you exactly what it's going to do. So if I have a function called convert to Morse, and it takes a variable called phrase, I can pretty much guess that what this function is going to do is convert that phrase into Morse code. All right? So let me run it, and let's see what it looks like. So I'm typing the word node right now. So node is the server implementation of JavaScript, and I'm typing morse.js, which is the name of this file. And so what that's going to do is it's going to run the code in this file. There's something called console log down here. What console log does is it prints whatever is between the parentheses. So between the parentheses we have word and Morse. Word and Morse is assigned to the result of calling the function with the string we can read code. So whatever this function returns is what is getting printed. So that's what it prints. A bunch of dots and a bunch of lines. Still looks confusing. Let's break it down. All right. So one thing you can do when you're trying to understand code, or as you're trying to debug code, is you add more console logs in. So something that we could add, which would make this a little easier, is to console log what current letter is. Now, we know that current letter is the phrase at the letter position, but it would be great to actually see that as we're going through this code. So here it is. These print on separate lines because it's getting executed every single time it loops. So the first loop, current letter is W, then it's E, then it's space, then it's C, A, N, space, all the way down. All right, so that's every single loop. So another thing you can do is add this in. This is a loop. And so that tells us that it's a loop every single time. It makes it a little easier. Now, we are looping through every single item in this phrase. So that's what that for loop's doing. It's saying as long as the letter position is less than the length of the phrase, keep going through and looping. And then change the current letter to whatever the phrase is at that letter position. Now, if current letter is a space, we want to add 3 spaces to word in Morse. So up here we've got word in Morse, and word in Morse starts as an empty string. Now what we're doing is, throughout all this code, every time that we get to something we want to convert to something in Morse, we add it to word in Morse. So here, we add 3 spaces to word in Morse. Down here, we're adding a dash to word in Morse. Down here, we're adding a dot. And down here, we're adding just a single space. All right? So there's a difference between a triple space and a single space. The single space happens, and you can actually see lines in my code editor here. The single space happens in this for loop, but outside of this for loop. So what it's doing is, it's adding a space between every dash or dot. Whereas up here, if it finds a space where the current letter is, it's adding 3 spaces. So when we look at our results, we're seeing a small space between every character, and we're seeing a big space where the actual spaces between the words exist. All right, let's see here. So if I were to console log now word in Morse inside of here, let's see here, I would want to do it, let's try it right here. 1 second. So this is going to show me what word in Morse is every single time we go. Whoa! All right. So here's a loop. And we get to the W. And then we can see what the current word in Morse is. It's a dot, then it's a dot and a dash, and then it's a dot, dash, dash. So when we get to the W, we are adding these 3 symbols to word in Morse, one at a time. When we get to E, all we add is a dot. When we get to C, we add a dash, then a dot, and then a dash, dot, dash, then, and so on. And so how is that happening? Well, if we go back here, what's happening is this. So the first thing we have is we have a W. And so we access the W, and then we say loop through the array, and then convert ones into dots and threes into dashes. So it's actually a loop within a loop. All right, we loop through every single letter, and when we get to a letter, we loop through the array that's connected to it. I'm going to repeat that one more time. So what we're doing is we're looping through every single letter, and we pause at every single letter because we're accessing it in this object, and we go through the array it's connected to, we loop through every item of that array, and we convert those things into dashes and dots. And that's why when we print at each section, we get to the W, and then we have to loop 3 times because the W is connected to an array of 3 items. We get to the E, and it's only 1 item, so it's 1 loop. Then we get to the C, and it's 4 items, so we loop 4 times within it. And so the inner loop where all of this is happening is right here. Because we're saying, as long as you have not gone past the amount of items in the array, so Morse code at current letter, dot length, because each of one of these is an array, take the current dash and make it whatever that item is in that array. So whether it's a 1 or a 3. And if it's a 3, add a dash. If it's a 1, you're going to add a dot. I see some nods. I see some confusion. I want you to give your partner a high five. Great job, everyone. All right, so that's it for me, but I want to introduce Yan. Connie was around earlier. He's part of Code Chrysalis. Felix, who's been recording, is the lead instructor at Code Chrysalis, and Yan is the CTO at Code Chrysalis. We'd love to have you join us for any of our workshops. We do a full stack immersive, but Yan will talk more about that. Thank you all for your time.
Well, I hope this appears. Is this the... All right. Magic. Yay. Okay. So let's give another round of applause to Krista for doing such an amazing job. Fun fact, she won an award for Teacher of the Year when she was in her first teaching career. So yeah, and that's pretty impressive. So I just want to tell you guys a bit about Code Chrysalis. Of course, there's more information back there on the table, but I just wanted to quickly go over stuff in case anyone had any questions. So we are a software engineering school. We're actually located about 4 minutes away from here. And we have 3 main missions in Japan. The first one is to create engineering leaders, and for us that means more than people with just technical skills, but also people who can communicate, as we all learned today, who have flexible autonomy, and who have empathy, because at the end of the day, when we are engineers, we are building for other people, so we need to think about our users. We also want to empower women and get them into more tech jobs so that they can play an active role in the creation of technology. And we also want to do a lot of community building. It's really important for us to give back, for us to share ideas and what everyone's working on. That's really important for us. We have 3 main programs. We have the Immersive, which is what we're most known for. It's a 12-week boot camp, full stack software engineering. It's a little bit exclusive. We don't take beginners. I'll talk a little bit more about that in a sec. And we also have a beginner program. So it's 5 weeks. This one is part-time, and it's open to people who have no experience in programming. And then lastly, we have an English communication course. It's not programming, but of course communication for us is super important. So I just want to quickly talk about the Immersive. This is the 12-week course that we have that we're most known for. Our students are from all over, and actually what's really interesting, even though our course is more advanced, you'll see that actually over 1/3 of our students are from a non-technical background. In our current class, we have a ballet dancer, and we actually had a ballet dancer in our previous class as well. In our current class, we also have a videographer, and we also have an English teacher, and they're in the same class as people who have a background in software engineering or who have a computer science degree. Another third of our class are people from what we call non-software engineering backgrounds, so non-software backgrounds. So we call that other engineering, right? A lot of mechanical, electrical engineers. And then the last third of our class are people who actually come from a development background. Either they were working as software developers or software engineers, or they have computer science degrees. Our admissions process is 2 steps. The first step is to pass our online coding challenge. So you have to pass our coding challenge in order to submit your application. We do this because coding is becoming a really popular thing to learn. And a lot of people want to learn how to code. But we really want to see people make an effort to learn. So there's a lot of free materials online, and you can learn all of this information on your own to a level to get in. After passing our coding challenge, then we have a series of technical assessments or check-ins. And basically, we see where you're at technically, and we see where you need to be. And if there's a gap there, we give you advice on how to close that. So what to practice on, what you're missing, things like that. And this is to ensure that when you enter our class, you're going to be ready to start running. You can learn more about our admissions process here. I wrote a little blog post about how to get in. And this is what our curriculum looks like. So before you even begin the course, we have a pre-course curriculum. This is about 1 to 2 months worth of homework that you are required to finish before you're allowed to begin. So it covers a lot of the fundamentals that you need to get started as an engineer. Things like Git, which is a program that allows us to control the different versions of our code. Also command line, so that fancy thing that Krista was using, like the black screen, that's the command line. HTML, CSS, things like recursion, that's all covered in pre-course, all these fancy terms. Our course is 12 weeks, and that's broken up into 2 parts, the first half and the second half. The first half is the full stack half, and this is where we bring you what is called full stack, which means you can work on the front end, which is all the, basically what you see on a web page. So the colors, the text, the moving menus, all of that is the front end. It's also, full stack also includes the back end, which is like the server and databases, basically where all the information about you is stored. So we cover all of that in the first 6 weeks. The second half of the course is where you take all of these different concepts that you've learned and you apply them. So all of our students are required to give a 45-minute tech talk on a topic of their choice. So people have done stuff on Kubernetes, on WebAssembly, and all kinds of really cool technologies. We also have a week called Polyglottal Week, and this is where students are required to learn a new language in 1 week and build something with it and present it at the end of the week. Because for us, it's really important to be a flexible engineer. So for us, instead of calling yourself a JavaScript engineer or a Ruby engineer, we want to create software engineers, which means that you can learn what you need to learn in order to solve this problem, right? Whether it is a particular language or if it's a particular technology. Oh no. My computer fell asleep. We also have a senior project, so students have about 3 to 4 weeks to complete a final project. And then, of course, in the second half, we help with job hunt. So we provide training on everything from technical and non-technical interviews, how to write your resume, salary negotiation, job hunt strategy. You can check out our full syllabus here. It goes into pretty good detail about, what happens every week. And, of course, our outcomes are pretty strong. So our students, a lot of them start from a non-technical background, and they end up working at really awesome companies as software engineers all over Tokyo and outside. On average, our students earn about 3 million yen more per year for junior level positions than if they were to go out on their own. And the reason why companies like us is because we train our engineers to embody 4 things. To not only have strong technical skills, but to be able to communicate. Things like being able to talk to people clearly and effectively about the code that they're writing or the ideas that they have, to be able to public speak. We also focus a lot on autonomy and a lot on empathy. So we work with a lot of really great companies, and we have also a lot of events. I'll finish up soon. So check us out. We're on meetup.com/codechrysalis. All of our events are free. We have English-speaking events as well as technical events for all kinds of levels. If you want to see our current crop of students give their tech talks, that's going to be March 2nd. It's Big Mini Conf. They are going to be giving the tech talks. So topics include 3JS, which is like 3D using JavaScript, so that language that you guys were learning today. You can do stuff in 3D using it, so they're going to be talking about that. Someone's talking about Kubernetes, a lot of other cool topics. And here's our information. So we have some upcoming immersive courses, and you can find us all over the internet. Yeah. And we also, more information for other courses is all the way back there on that table. And I'll be around to chit-chat after if you have any questions. Anyhow, I'm done talking. I would like to thank Tucci and the rest of the crew from Mercari for helping with setup and check-in and all of that and providing this amazing space. I would like to also thank Tucci and Himi and Jeanette, and you guys are everywhere. All the other Women Who Code people for making this event so awesome. And thank you, Krista, for having such an awesome workshop. Thanks for coming today. I hope you guys learned something. I hope you guys get energized, go out and code. Yay!